So today I am talking about petrology in field of engineering geology. So petrology. So petrology is the branch of geology that deals with various types of rock and their origin, composition, texture, classification, and mode of occurrence. Magma. Magma is the hot, mobile, molten rock that exists below the Earth's surface. Magma remains in the molten stage until the environment remains unchanged. As soon as there occurs change in environments like changes in temperature, pressure, it converts it into a solid bodies called primary or igneous rock. When the magma is forced out to the surface, it is called lava. Acidic magma, SiO2. 65 to 75% rich in SiO2, NaO2, Na2O, and K2O, example granite. So, intermediate magma SiO2 55 to 65% rich in SiO2, Na2O, K2O, as well as CaO and Al2O3. Example andesite. Basic magma SiO2 45 to 55% rich in CaO, MgO, and FeO. Example basalt. Ultra basic. SiO2 is less than 45%. Large amount of FeO and MgO. Example peri peridotite. So rocks are rocks are aggregate of minerals with more or less definite composition. Rocks are made up mostly of crystals of different kinds of minerals or broken pieces of crystals or broken pieces of rock. Some rocks are made of the cells of once living animals or the compressed pieces of plants. Rocks are divided into three basic types: igneous, sedimentary, and metamorphic, depending upon how they were formed. Rocks are recycled from igneous to sedimentary to metamorphic and back to igneous again, which can be better explained by rock cycle. The rock cycle illustrates the relationship between Earth's internal and external processes and relates the formation of the major rock groups to external weathering, transportation, deposition, and internal process melting metamorphism. So igneous rock. Igneous rocks from the Greek word fire. From the Greek word for fire. Form from Igneous rocks are formed when hot molten rock magma crystallizes and solidifies. The melt originates deep within the earth near active plate boundaries or hotspots, then rises towards the earth, then rises towards the surface. Igneous rock are divided into two groups, intrusive or extrusive, depending upon where the molten rock solidifies. So, igneous rock classification. Igneous rock are classified according to the mode of occurrence, texture, mineralogy, chemical composition, and the geometry of the igneous body. According to mode of origin, extrusive igneous rock. Extrusive or volcanic igneous rock is produced when magma exists and cools outside of or very near the Earth's surface. These are the rocks that forms at erupting volcanoes and oozing fissures. The magma called lava, when molten rock erupts on the surface, cools and solidifies almost instantly when it is exposed to the relatively cool temperature of the atmosphere. Quick cooling means that mineral crystals don't have much time to grow, so these rocks have a very fine grain or even glassy texture. Hot gas bubbles are often trapped in the quenched lava, forming a bubbly vesicular texture. Pumice, obsidian, and basalt are all extrusive igneous rock. Intrusive igneous rock. Intrusive or plutonic igneous rock forms when magma is trapped deep inside the earth. Great globs of molten rock rise towards the surface. Some of the magma may feed volcanoes on the Earth's surface, but most remain trapped below, where it cools very slowly over many thousand or millions of years until it solidifies. Slow cooling means the individual mineral grains have a very long time to grow, so they grow to a relatively large size. Intrusive rocks have a coarse grained texture. Uh, the image at right shows granite and intrusive igneous rock. Hypabasal igneous rocks are the type of intrusive igneous rock other than plutonic which is formed by cooling of magma beneath the earth's surface at shallow deep. According to silica percentage, one simple classification is based upon the silica SiO2 content of the rock. Rocks with less than 45% by weight SiO2 are termed ultra basic. 45 to 52% SiO2 basic, 50 to 66% intermediate, and more than 66% acidic. The terms acidic and basic are not intended to express the idea that the rocks are acidic or alkaline in the customary sense. They are employed merely to describe the silica content of the rock. According to mineral content, felsic rock with predominance of quartz, alkali feldspar, and or feldspar towards the felsic mineral feldspar silica. These rocks, example granite, are usually light color and have low density. Mafic rock with predominance of mafic minerals, magnesium, iron, pyroxenes, olivines, and calcite plagioclase, plagioclase. These rocks, example basalts, are usually dark color and have higher density than felsic rocks. IUGS classification. The classification of plutonic and volcanic rock, which is based on the model mineral proportion of quartz Q, alkali feldspar A, and uh, pla, 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 plagioclase P, or of alkali feldspar A. Plagioclase P and feldspathoids F mostly used to classify plutonic rocks, pane, phaneritic rocks, but are also used to classify volcanic rock. The plotting of rock modes on these triangular diagrams is simpler than it may appear. The three components Q quartz plus A alkali and A K feldspar plus P plagioclase are recalculated from the mode of sum to 100%. Each component is represented by the corners of the equilateral triangle, the length of whose side are divided into 100 equal parts. Any composition plotting at the corner therefore has a mode of 100% of the corresponding component. Any point on the sides of the triangle represents a mode composed of the two adjacent corner components. For example, a rock with 60% Q and 40% A will plot on the QA side at the location 60% of the distance from A to Q. So here is a figure. Igneous rock texture. The texture of a rock refers to the details of its visible character, the size and quality and interrelations of its grain and the fabric they form. Larger, larger scale features such as fractures and layering are considered rock structures. Textures are studied on the basis of following headings: based on crystallinity, based on granularity, crystal size. So, based on crystallinity, the percentage of crystals versus glassy minerals materials in the rock. Hollow crystalline, coarse grain, 100% crystalline. Example: granite, gabbro. Hypocrystalline, partly crystalline and partly glassy. Example: basalt. Hollow hyaline, 100% glassy. Example: rhyolite. Based on granularity, crystal size, the fineness and coarseness of the crystals that can be seen by naked eyes. Phanerotic grains of minerals can be distinct by naked eyes. The coarse grain is called phenocryst, and groundmass grain that surrounds the phenocryst is called matrix. Coarse grain is greater than 5 mm, medium grain is about 1 to 5 mm, fine grain is less than 1 mm. So, aphanetic grains of mineral cannot be seen by naked eyes. Based on crystal shape, euhedral. All the faces of the crystal are clearly developed, also called ideomorphic or automorphic crystal. Subhedral. Some faces of the crystals are developed, also called hypidiomorphic or hypotomorphic crystals. Anhydral. None of the faces are clearly developed, lack crystalline outline, also called oleotropomorphic or xenomorphic. Xenomorphic. Genomorphic. May based on mutual relationship arrangement. Equigranular in equigranular. Equigranular. Development of crystal on a uniform size. In equigranular. Size of the crystal different from grain to grain. Seriate. Crystal or principal minerals show continuous range. Porphyrite. Large crystal surrounded by small crystal. Poi, Poikilotes. Small crystals are developed within large crystal randomly arranged without uniform distribution. Ophitic. Similar with pocolite texture with uniform distribution of crystal. So here is a figure. Order texture, tabular texture, equine texture, fibrous texture, glacier texture, vesicular texture. So tabular texture, a term used to describe grains with rectangular tablet shapes. Equine texture, a term used to describe grains that have all of their boundaries of approximately equal length. Fibrous texture, a term used to describe grains that occur as long fibers. Glassy texture, due to very rapid cooling, uh, magma cools so fast crystal don't have time to form. Obsidian, volcanic glass forms this way. Vesicular texture, pool of rounded holes, vesicles, forms due to escape of gas bubbles during cooling of lava. Pumice is a light color rock with this vesicular texture. So, so types of igneous intrusions. Igneous intrusions are rock bodies that form from crystallization of magma at depth within Earth's crust. They are categorized based on their shape and overall size. They come in a variety of shapes and sizes. This discordant, cut across pre-existing fabric or of rock layers. Dikes are small igneous intrusions that cut across rocks into which the magma intrudes. They are commonly sheet-like, one only a few members wide, but possibly laterally extensive. Think of magma embedding a particle or near particle fracture in rock. Igneous rock will fill the crack due to crystallization of magma. One would call the rock body or dike. Stalks are fairly large, tens of miles. Igneous intrusions that cut across pre-existing rock layers. In size, they are one the order of an individual mountain peak. Bathyolites are huge igneous intrusions made of many stalks. Their size is one the on the scale of an entire mountain range, hundreds of miles. Concordant, follow pre-existing fabric of rock layers without interpretation of layering, parallel to pre-existing rock layer. Seals are also small igneous intrusions. They are sheets of rock that, unlike dikes, are parallel to pre-existing rocks. Think of magma embedding sedimentary rock by spreading out between rock layers. That magma will cool to form a seal. Lago, lago, Lacolites are rather large mushroom-shaped intrusions that poof off in the center due to the gases. Lopholites are very large inverted mushroom-shaped, sponge-shaped, funnel-shaped intrusions that sag down in the middle because of dense rock. Pacholite. A pacholite is a intrusive body parallel to the bedding plane or formation of bolted country rock. It is a typically lean-shaped boulton that occupies either the crest of an anticline or the trough of a syncline. In rare cases, the body may extend as a seal from the crest of an incline to the trough of a adjacent syncline. Metamorphic rock. The mineralogical and structural adjustment of solid rocks to physical and chemical conditions that have been imposed at depths below the near surface zones of weathering and diagonals. The word metamorphism comes from the Greek word meta, change, form. So metamorphism means to change form. In geology, this refers to the change in mineral assemblage and texture that result from subjecting a rock to conditions such as pressure, temperature, and chemical environment different from those under which the rock originally formed. Metamorphic rock form beneath Earth's surface when other rocks are transformed by heat, pressure, and or chemically Active fluids. Types of metamorphic structure: foliation, lineation, cataclastic structure, cysto structure, nice structure, अनि marcelo structure, aguin structure, granular structure. So, foliation. When platinly laminar or flaky minerals, example seed silicate minerals that the mica biotite and muscovite chloride talc and so we will talk about types of metamorphic structure in our next video.